Bismillah ar-Rahman ar-Rahim. Good morning, everybody. Today, inshallah, I'll complete with you the polymers. We started in the last period to talk about polymers, chapter 21, page 169. Chapter 21, page 169. I talked with you with polymers and I said to you that the word poly means many. And I have a large molecule consists of repeated units, what we call monomers, okay? And I said to you, we have natural polymers like DNA, like protein in hair and in muscle fiber, and we have synthetic polymers like plastic, okay? I said to you also that we can make polymers by two ways: additional polymerization and condensation polymerization. When we started to talk about additional polymerization, the first thing we took polyethylene. Okay, today inshallah we will talk about polypropene. Polymerization of propene. Okay, our lesson today starts in page 170 because in the last period we stopped at the uses of polyethylene. Okay, and we said we have high density polyethylene and low density polyethylene. Okay, inshallah today we will talk about polymerization of propene. It's a very easy lesson and short lesson. Okay, I want from you to know this, that propene is prop, so we have 3 carbon atoms, and the suffix "ene" explain that we have double bond. Okay, carbon double bond. So propene is alkene, contain 3 carbon atoms and a double bond. Maybe the double bond with the first carbon, or the double bond, yes, here we make it as a first carbon, like here. Okay, if we count from right, it will be the first carbon. Okay, so we have CH2 double bonding, CH3. The structural formula first, the molecular formula, we have 1, 2, 3 C, okay, and the general formula for alkene is CnH2n. So the number of hydrogen is 6, as you see here, 3 plus 1 plus 2. So we have 6 hydrogen. The structural formula for propene, I have C with single bonding, so it will carry the 3 hydrogen, and this C double bonding here and 1 bond here, so 3. The fourth one carry hydrogen, so we have just CH, and this C is CH2. Okay, we can find the modified ethene molecule like this. Okay, it will change into modified ethene, not prop. Prop, a long chain contain 3 carbon, but here we have modified ethene, just 2 carbon atoms with the double bonding. I have H and H, this is H and H, okay, and this H with the second carbon here. What about this? I'll change it into methyl group. So we have modified ethene molecule with methyl group. Okay, let's see the polypropene. The polypropene has another name, what we call it polypropylene. Okay, look here. We have carbon, this is carbon, hydrogen up and hydrogen down, double bonding, carbon with hydrogen down, and methyl group up, like this. Okay, so from propene we have modified ethene with 1 CH3 group. Okay, this repeated units, this repeated monomers make what we call polypropene. As we said in the last period, here under pressure and temperature, here we said with the heat and the pressure and initiator, okay, and I said to you initiator is not a catalyst, but it is only used to get the process start, okay, and used up, enter in the reaction, not like the catalyst. Here also under heat and pressure, okay, the double bonding will split and make more and more chain. Double bonding will split like this and make more and more chain, like this, like this, like this, like this, okay. I said to you, we put in this in, explain the number of the monomers repeated. You will find the definition in page 169. Okay, here N represents a large but variable number. It simply means that the structure in the brackets repeated itself many times in the molecule. Many times equal what? Equal this N. Also here, in case of polypropene, we will take the modified ethene before it N, and when under heat and pressure split the double bonding, it will change into CH3H, CHH, all N, like this. Okay, and this N explain the number of repeated units. Okay, as you see, it's very easy. Just know we have propene, which is alkene, 3 carbon atoms, carbon-carbon double bonding. This is the full displayed formula, structural formula. We have modified ethene. Instead of this CH3, I hang it here with this carbon and make it like this, okay. Polypropene, we put the propene, which is the monomer between the brackets, has another name or known with this name or by this name, polypropylene, okay. As you see here, under pressure and heat, the double bonding break to make more long chain. We will use the same brackets to write N, which is the number of repeated units. In use of polypropene, I don't want anything except this. Polypropene, we give it PP as abbreviation, okay. It is stronger than polyethylene. We said in case of polyethylene, we have two kinds, low density polyethylene and high density polyethylene. Here we have polypropene, okay, and this is stronger than polyethylene. We use it in what? We use it in making groups and crates. We using in making groups and the crates like this, as you see here. I don't want anything else from this lesson. I want from you to know that polymerization of propene, the repeated unit is propene, and it is modified with ethene into ethene and one group CH3, as you see. Under heat and pressure, the double bond break into single bond to make more and more chain. This is the general formula for the polypropene, which give it PP. I want from you to know that polypropene is stronger than polyethylene, and we use it in making groups and crates, as you see here in these two figures, groups and crates. Okay, this is our lesson today. I think it's very short and easy lesson. Thank you. Best wishes.